In a world where our data is always flying around constantly at risk, what if the solution wasn't some crazy complex new app, but, well, a simple sketch? Today, we're going to unpack a blueprint for a much safer internet, one that all starts with proving you are who you say you are, every single time.
I mean, it's a question we all think about, right? You hit send on an email, you upload a photo, you post an update, and then what? Where does it actually go? Who's looking at it? And maybe, most importantly, can you even prove it's still yours? That feeling of losing control is exactly what the protocol we're about to dive into is trying to fix.
And here it is. It might look like just a doodle from a notebook, but this one diagram maps out a totally new way to think about how our data travels online. Every single line, every box here has a job. So let's follow the path together and see how it builds this chain of trust, starting right at the source, the data's owner.
Okay, so this whole system has a name, the Secure Data Transmission Protocol, or SDTP for short. Now, the main idea sounds pretty simple, but it's actually a huge shift in thinking. The idea is, before your data even leaves your computer, you digitally sign it. That signature becomes like a digital passport that travels with your information, proving where it came from at every single stop along its journey.
So, where does this whole journey kick off? Well, according to this blueprint, it all starts with the data owner. It starts with you.
If we look at the top left of the sketch, it's all right there. It begins with the data owner and their private data. The very first thing that has to happen before anything gets sent anywhere is the creation of a data signature. This is basically a unique digital seal that gets stamped on the data, locking the owner's identity to that specific piece of information. Without that seal, the data just doesn't go anywhere.
Probably the easiest way to wrap your head around this data signature is to think of it like an old-school wax seal on a royal letter. It wasn't just there to keep the envelope closed, right? The unique design on the seal proved exactly who sent it. And if that seal was broken, you knew for sure that someone had messed with it. This is basically that, a medieval guarantee of authenticity, just built for the digital age.
So how is this signed data actually packaged up for its trip? The sketch calls it a data payload, and it's essentially a bundle with three key things inside. First, you've got the data itself, the actual information. Then you have the standard, which is just the universal format it's in. And of course, you have that all-important signature. Everything needed to verify it is packed in right from the very start.
Okay, so our digital letter is sealed, it's packaged up, and it's ready to go. But here's the thing, it doesn't just get dropped into some public mailbox. It enters a really carefully designed, secure pipeline. Following the lines on the diagram, that payload moves from the owner over to a private data server. That server then uses the SDTP standard to send it out into the wild. Think of SDTP as the armored truck for your data. Its only job is to get that package from point A to point B securely, making absolutely sure that signature, that wax seal, is never broken while it's in transit.
All right, now once the data arrives at its destination, it has to pass a supercritical test. This is where a modern gatekeeper steps in to check its passport. And this is the moment of truth, the verification step. After zipping across the internet, the data doesn't just get to go wherever it wants. First, it hits a checkpoint, here, labeled data processing, and you can see it's managed by an AI. This looks like it's a really critical step before the data can actually be used by anything. So what's this AI actually doing? Well, it's not reading your messages or looking at your photos. Think of it like a bouncer at an exclusive club who only checks IDs. All it does is look at the data's signature, its digital passport, and asks one simple question. Is this authentic, and does it really come from the person it claims to? If the seal is intact and the signature is valid, it gets waved right through. If not, access denied. It's a simple but incredibly powerful security check.
So our data has been created, it's been signed, it's been securely transmitted, and now it's been verified. It has passed all the tests. Now, finally, it's ready to be put to use.
So the final piece of the puzzle shows us what happens after the AI gives the green light. The verified data flows into what's called a data consumption pipeline, and this is a really key detail here. It can then be fed into any kind of application you can think of, from the regular web to social media platforms, all the way to decentralized Web3 apps. This design means that this layer of trust isn't locked into one type of technology. It's designed to be universal. You know, when you trace the whole process from start to finish, it becomes so clear that the data owner's signature is the one constant. It's the golden thread that connects everything. From the second it's created to the moment it's used, that signature creates an unbreakable, verifiable link straight back to the person who created the data. It's the ultimate source of trust in this entire system. So what's the big deal here? Why does a system like this even matter? Well, it really seems to be about shifting power back to the user. When your ownership is maintained from the very start to the very end, and every single transaction is verifiable, you start to build a web that is fundamentally more trustworthy. It gets to the root of problems like data tampering and misinformation by making authenticity the default setting, not an afterthought.
This whole blueprint, it suggests a future where every single piece of data has a clear, verifiable owner. A future where trust isn't just a promise from a company, but something that's baked into the network's architecture. So the question this leaves us with isn't just whether this kind of tech is possible, but what kind of internet could we build if we started making verifiable ownership the rule instead of the exception?